So for this example, I'm going to demonstrate how to test capacitors. So I'm going to turn the knob to the capacitor selection. Comes on. It's hard to read, so I'm going to turn on the backlight. And what's interesting to note, you see we have a reading of 0.018 nanofarads with nothing attached on the leads. So that's the capacitance that we have, and you can see if I move test leads around, it's native to there. Now a 0.021 nanofarads is also the same as saying 22 picofarads. So which is kind of interesting. The range for the lowest setting of capacitors are supposed to be 2 nanofarads. So just to challenge everything, I selected a capacitor that's 10 picofarads, and so that's kind of like in the range of what we're reading right now. So I'm going to put those on the clip and just see what it does different. And we're going to see some limitations of the digital voltmeter for doing really teeny tiny capacitors. 0.023.024, and then I'm going to unclip it. And it goes down a little bit. So we were reading 10 picofarads. That's kind of adding up in that range. So that's kind of a challenge for this meter to read that. Here is a 20 nanofarad capacitor. So that one is this one over here. And what I'm doing with these capacitors, they're ceramic, so it doesn't matter what the polarity is. So I'm just going to attach the leads to them, like that. And it reads 19 point, it's reading 20 nanofarads. That's a little change as I move the leads around. So that's really pretty good. It's on the low end. And we try another couple capacitors that are pretty common. These are electrolytics. They are polarity sensitive, and you can see there's a negative marking on there, so we want to put the minus lead on there. This is the electrolytic. This one is 1 microfarad. That is the negative lead, so I'll put the negative clip on there. Then the positive lead, and it should read about 1. And there it is, 1.05. So that's really good. That's within 5% of what it stamps, so that's pretty accurate value as far as that capacitor goes. They're pretty flexible on what their percentage values are. Now this is a 20 microfarad, so we'll do the same thing. It's got a polarity minus. Let's see how well it does. And there the meter's reading it, and there it changed to microfarad. Whoop, I don't want to hold it, I want to get the light on. Microfarad, it says 26. That's probably within the range of these capacitors as well. Capacitors are not that accurate on their ratings, especially the electrolytics. Okay, so here, that one was a 20 we did, so we did a 1 of 20, and now there's a 1000. So let's see how that does. The plus side is over here, so I'm going to clip that, see how that does, and we'll see how the meter does with 1000. Takes a little bit, now it's reading it, and it comes back, it's changed to 1 millifarad, MF, not microfarads, and it's reading 0.9747. It just so happens that 1 millifarad is the same as 1000 microfarads. So actually this one is almost dead nuts on. So that's pretty cool. So we'll do one more just as a sample. And it says there's a spec sheet that goes over all these ranges. So we've kind of hit the sweet spots. We kind of actually went lower than we possibly could, and then hit some common capacitor values. Now I'm going to hit a little bit of a whopper guy here. This is 100 volt DC. This is 2000 microfarads. This other one was just 1000. So we're going to see how this one handles it. It also says plus or minus. So I'm going to go ahead and pop that on there, and then pop this lead on here. Let's see how this one does. It's thinking about it. It's thinking about it. Come on. Now I made note in the spec that as you get up to the lower, even to 20 millifarads, this is 2 millifarads, but if you get up to 20 in that range, you have to give it 30 seconds to read. So it actually is pretty good. You notice as we've gotten bigger, we've taken a little more time to make that reading. That's pretty cool. This is a 2000 microfarad. Don't want to hold that value, I just want to light it up. Okay, and so this says is 2 millifarads, which is really good. Now, we haven't hit the full range of the capabilities of the multimeter, but it's doing pretty darn well for selecting really low ones, mid-range, and high ones. So this is how you check capacitors. Thank you. Also wanted to make a note, as we're checking capacitors, be careful. I'm going to go over to the voltmeter and select DC. So I just charged, well, as we were testing it, we've been charging it. So I'm going to go over there and see that we have actually 3.3 volts on that cap. So be careful with these capacitors. They are getting charged up a little bit whenever you're reading them. You can discharge them with a resistor.